Hey everyone, and welcome to the finalist voting for the Maven Power Outage Challenge. So the challenge objective, which is what we're going to use as the criteria for the voting, was the following. So for the Maven Power Outage Challenge, you'll be playing the role of a senior analytics consultant hired by the U.S. Department of Energy. They told you that they have event-level power outage data going back to 2002, but have struggled to make sense of it due to severe issues with the data quality and integrity. So the entrants needed to do three things: consolidate and clean up the raw data, create a dashboard or report to help the Department of Energy understand patterns and trends around outages, quantify their impact on communities, and identify possible weak points in the grid. And finally, to explicitly call out any caveats or assumptions they made while cleaning the data. Now let's take a look at the data. Now, typically, I go to view the full details here. For the data for our challenges would require some minor cleaning and prep, as most of that is done on our end before we actually upload the data set to the playground. This time around, though, the data set was compiled exactly as reported by the US Department of Energy to expose users to the types of data quality issues that are often encountered in the real world. So the download dataset file, if you have it here, actually included an Excel file with the annual summaries on electric disturbance events from 2002 to 2023, each one in a separate tab. So as you can see, if I jump over to Excel here, data in each one of these tabs isn't in a perfectly tabular format, and there are tons of data issues. If you go on to the next tabs, you'll actually find that the columns aren't exactly the same from year to year, which makes it even harder. So that's the challenge and the data set this time around. You can also scroll through the submissions down here. If you participated and you don't see your entry here, just make sure to go into your project settings and select the Maven Power Outage Challenge. And most importantly, if you tried to participate and found it challenging to clean the data, then here's a pro tip for you. In these tough data cleaning scenarios, always try to take what's called the MVP approach, which stands for minimum viable product. So get the data in a good enough spot so that you can make a report out of it that's useful, at least in some capacity, in this case, the Department of Energy. Try to quantify how much of the data quality issues remain, and then just iterate. Go back, clean another piece, update the report, and then just keep doing this. Because otherwise, if you try to handle all of the data quality issues at first, which some people may have tried to do here, well, then you might never finish, and then they get no use out of the data, which is where they started anyway. So that's my advice. Now, we already got a list of 5 finalists that we're going to be evaluating today, but I'd like to also call out some honorable mentions before we begin. I'm going to start with Margaret Efron, who included a really thorough and captivating project description, but ultimately lacked a final deliverable to tie it all together. Oleg here showcased what I think was the MVP approach by putting together a report even with the missing data, and then clearly addressing these steps that they did and didn't take in this FAQ section here. We've also got Jack Toomey here, who very deliberately structured this project precisely around the 3 callouts in the project prompt. We've got Danish, who not only had a great final report, but also outlined all of the data cleaning steps in his report, and I think made some very clever tweaks and assumptions in the data. And finally, Abhilasha had, I think, outlined the assumptions made for the data cleaning here, but they kept the actual steps and the code and all that in a separate document, which just makes the project much more approachable for anyone, which I think is a great best practice, especially for these very complex project pipelines. So those are the honorable mentions for the Maven Power Outage Challenge. Now let's dig into the 5 finalists, starting with Jasmine. I'll hand it over to Lauren.
So I'm really excited to kick us off by talking about Jasmine's entry into the Maven Power Outage Challenge. When I was reviewing her project, what I really wanted to keep in mind were those 3 objectives that we had given. So really, did Jasmine clean the data and explain how she did so? Did she explicitly call out any caveats or assumptions that she had made? And did she create a dashboard that really accomplished the requested tasks? So digging into each of those categories briefly, I'll kind of start with the cleaning and consolidating of that data. In her about section, Jasmine notes right off the bat that the data needed a lot of cleaning, and it did. She is totally right about that. And she really kind of walks us through each of the steps that she took. All of them were done in Excel, which I thought was really great. It's a really approachable way to handle this. So she kind of talked about exactly what Enrique mentioned, how she ordered her columns, how she managed the number of columns, and how they differed from year to year. She talked about how she dealt with event and restoration dates and times, how she quantified that megawatt loss, how she kind of categorized all the different events into a smaller number of categories. And lastly, how she kind of created her table, her affected states table. She used a dynamic array to do that. And you'll kind of see, she talks about the different kinds of functions that she used. And it was really just a great way for us to see in detail how she chose to think about this. So I think she did a fantastic job with that data cleaning aspect. The next thing that I looked at when I was kind of reviewing this project was if she's explicitly called out those caveats. And I think she also did a really great job with this. So for instance, when she was looking at the NERC regions, she noted that some of the ones from our data showed some old or wrong regions. And so she made sure that she corrected that and called it out. She also talked a lot about how she handled missing data and blank data, and kind of what her thought process was behind that. And then moving into that actual dashboard, I really love this section right here. So Jasmine walked us through exactly what her objectives were. She specifically wanted to accomplish the ability to filter by date and time. She wanted to be able to see the total number of affected customers, the total number of events, the status of the restoration, the number of events in an affected state in order to find those weak spots in the grid, which was part of that prompt. And she also gave us a really interesting insight into why she chose her color scheme, which I thought was really, really interesting. And I really enjoyed kind of reading about that. So she said specifically that she went with yellow because it represents energy. I thought that was just a really clever use of color. And then to contrast it with dark purple, I thought was really great. She also called out some insights. So she did this in her about section. And she talked about, the seasonality of events, the regions where the most events occurred, maybe why those regions were more heavily affected. I think that this was all really, really great insight. I do wish that there was maybe a little bit more analysis done here. For instance, she said that the most affected states are California and Texas. And while that is true, they are also the biggest and most populated states within the US. So it might make sense to kind of dig into that data a little bit more deeply and kind of consider that angle from, population standpoint or density, something like that. So finally going to Jasmine's actual dashboard, I think that her use of color was very smart. I think that she really accomplished her objectives here. She mentioned in her about section that she used primarily chart bar and column charts, which absolutely is a great fit for what she was trying to do. She definitely gave us a look into exactly what she wanted, the affected number of customers, the total number of events, how different regions kind of performed. But what I really liked here was this bottom chart. So really looking into the time frames in which certain events happened. So we can look at that by year, by month, by which day of the week the most events occurred, and by the time of day. So I think that, with the interactivity of her dashboard, being able to drill into different regions to kind of see how they performed, being able to drill into which types of events happened, being able to look at both the number of customers affected and also the demand loss. All of that was really great. And it was just a lot of fun to kind of use and dig around and kind of play in. So I thought it was great. One thing I will say is that I think with a little bit more time, Jasmine could have made some tweaks, kind of made this a little bit more organized. But overall, it really did make me kind of want to dig in and explore the findings that she has listed. Last thing that I kind of want to bring up here, and this is just kind of a personal thing that I really enjoyed, at the very, very, very bottom of her about section, she kind of went over this summary of what she learned, her journey along the way, any kind of challenges that she ran into. And I thought that this was just a really, really great thing for her to do, to say this was a tough challenge. The data cleaning was really tricky, but it was a lot of fun to kind of figure out ways to automate it. And I think she also kind of calls out some collaboration and some community building that she did in kind of commiserating about this data cleaning that she had to do. So overall, this was an awesome entry for Jasmine, and I really enjoyed getting to kind of dig into it more.
Okay, so next up we have Martin Livingstone. So like many other participants who came a long way in our finalist conversations, Martin had a really huge walkthrough to present in his about section, where he sort of walks us step by step into what he did. He actually starts by introducing the data, the topics, all of that fun stuff, the assessments that he did, the assumptions that he made, and he actually goes very detailed into what kind of problems were present in the data and what needed to be done to clean up those problems. If you can see this data cleaning section, so there's actually a lot of these mentioned right here in the About Us section. Another thing that he is sort of pointing out very explicitly is what he started with, and then how his columns look like at the end, specifically what he chose to keep, what he chose to add, what he chose to remove altogether. I think one of his assumptions that is important to mention is that he didn't actually analyze the entire period for which we gave data. He got rid of 2023 on account of it not being an entire year, which I think was really smart, because as we've seen in some of the previous challenges, people tend to ignore these things, and then the results can be a little bit skewed, giving us a sense that there is something like rapidly dropping, that some measures are rapidly dropping, when in fact it's just an incomplete data set. From there, he moves on to talk about his exploratory data analysis dashboard development. I'm going to check that in a second on his dashboard. There is one very interesting call out in his summary, where he says, I was surprised by how dirty the data was, particularly from years 2002 to 2010. I guess the DOE recognized this, as the quality of the input improved dramatically from 2011 onwards. And this is very important to mention, because all the cleaning wizardry aside, if you have a problem at the source, right, then you're cleaning, you're sort of healing the symptoms, not the real cause. And I think this was a very important thing to mention. This was very smart, also very unique. I don't think I've seen these comments before. Now I'm going to actually open his dashboard in a separate window to make it a little bit bigger, because there is a lot on it. It's probably one of the cleanest dashboards that we've seen in this challenge. It is very explicitly split into 3 separate sections, and each section starts by answering the very question that it talks about, right? So at the top we have these causes of power outages, and then it says there's an upward trend in power outage incidents across the US that became more pronounced since 2018. And then he goes on to visualize all of this. So Martin probably had the lowest number of categories that he used to group his events into, right? So originally in our data set, there are a lot of event types, a lot of those overlap or just require cleaning of any kind. So he actually compiles all of these into weather problems, storms, high winds, lightning, floods, everything natural, operations. So this is any kind of technical malfunction, equipment malfunction, stuff like that, and human attack, something that is caused by human action, either vandalism, physical attack, cyber attack, stuff like that. So by having just these 3 overarching categories, that's what's actually enabling him to be as crystal clear and as crisp as he is moving forward. So then breaking down stuff by just 3 categories, it's actually quite easy to go through all of this. One thing that I will call out are these 2 charts here. So there is a stacked bar and a line chart, which essentially almost tell the same story. I think he could have just stuck with 1 chart. There is an interesting call out below this line chart here that says there are only 3 incidents due to human attacks reported before 2011. And that's very important, because just looking at the chart, you could assume that there is some sort of an error in the data or that there is a problem of some kind. But by calling this out, we now understand that that is actually intentional and that's the correct way. Still, I think maybe that going with just one chart would be a better option as a piece of feedback, nothing more. Moving forward, we see how our customers were affected. What kind of power did we lose? Did we lose over time? Again, split by those three categories, we can easily see that the weather is the number one culprit in all of those events. And then we have this percentage of total demand loss, where operations problems sort of almost catch up with the weather, and probably all due to this northeast blackout. I'm not from the US, so I'm not as familiar, but I'm imagining some huge event that took place in 2003 that caused all of that calamity. As we can see later on, the chunk of these operations in the bar chart isn't as pronounced as it is in 203. So really smart way to sort of call out this very interesting case here. In the second part, so let's call this section number 2, he talks about seasonality, right? So the influence on seasons, on power outages. And there is this stacked bar chart, which is like really rich. There's a lot of unpack there. It's quite fun, if I'm honest, to look at. So we have basically, again, data over time. This is customers affected by power outages over time. But then we have these little icons all over the place, which add a ton of context, right? So we have these notable hurricanes or weather activity, which we see the years that had those events, and then these like brown circles with numbers at the top. Those are actually the hottest recorded years since United States keeps this kind of record. So we can actually see that 8 of the hottest years ever happened in the last 20 years, which is really interesting. It's also very much in line with what we have been talking about global warming and everything in our previous challenge. But that aside, it's really fun to unpack all of this stuff. For example, we can see this is what when 2008, when the Hurricane Ike happened. This bar is the highest, so this is where the most people were affected by power outages. On the other hand, we have like year 2017, which also had a Hurricane Irma, and was the 4th hottest year ever, and the problems were nowhere near as numerous, or actually the number of people wasn't as big as it was in 2008. So you could look at this for quite a while. It's really an interesting chart. Probably one of my favorite in the entire challenge. The heat map is a nice touch. We see that the peak season is like summer and peak time of day, which all makes sense. But there are these helper callouts here, which draw our attention on, for example, the month of February, which is in the winter season. And while in the summer, the events tend to happen more often during these peak hours, during winter, they're sort of more widespread throughout the day, regardless of the actual time. So very interesting thing to call out here. Finally, weak spots is something that Martin defined very specifically. So there were different approaches to this during the challenge. Some people leaned on geography, some people leaned on the aging network and stuff like that. But Martin actually defined a weak spot as a power outage that was caused by an equipment failure. So very specific definition, something like machine malfunction, fuel supply breakage, or even human error. But there is a very, very specific definition of what it is here. And then he breaks the number of failures over 2 decades. He actually breaks the decades in 2 just so we can see how the top countries changed over that time. We can see that California is unfortunately always at the top, but then there are some changes afterwards. Overall, a very interesting approach to the whole thing. Now, one general overarching piece of feedback that I would give here is that the whole dashboard is just slightly lacking like a big numbers, like something that jumps out that like immediately draws attention, something that would be the most important metric or the most important number or numbers or trend that we should be paying our attention to. As it is, it's like everything on the dashboard has the same importance, let's say. But other than that, I think probably, if not the most, then among the most polished and easy to consume dashboards in the entire challenge. Excuse me.
Okay, we've got another great entry here to review. This one has been submitted by Katie Welch, but unlike some of the projects that we've already highlighted so far, you're going to see that Katie hasn't provided as much explicit detail about the steps that were done to clean the data for this project. But I think we kind of know why. If we go down into the About This Project section, we see here highlighted that Katie at the beginning outlines a strategic decision to focus in on only the data that was produced in the last 10 years. And that's from the overall 20 years that was provided in the data set. I think we've already heard Bronislav mention that the data from that area is a little bit different. The goal here is really to get more recent information and potentially something that's a little bit more relevant when you're looking at establishing what does the current status of the US grid system look like. But that nice add-on effect meant things like the columns were more consistent, the information was given in a list or a spreadsheet form as opposed to that more like report style. And there was already some existing refinement of the categorization used for things like event type. So all these things really supported Katie's planned analysis to focus on what can we currently understand about the US grid system, and it likely decreased the overall burden for cleaning. And that's what we've heard described by some of the other projects here. So a really astute decision up front here, Katie, that allowed you to focus when preparing the data. But of course, we know it still took a lot of time to get this data loaded and transformed. So if we go down to the bottom, we can see that Katie is mentioning using multiple analytical tools for cleaning and leveraging the data modeling capacity in Power BI. So this was a great way to highlight the range of tools that you're comfortable working in, Katie. Well done. In a future iteration of this, it would be awesome to see if you added some details about the steps that you went through in those different tools, about how your data cleaning was conducted. So let's jump over and take a look at the dashboard that Katie created. And one of the first things that we notice here is that even though there was this like really conscious decision to focus on the most 10 recent years, we're still provided with a high level view across the entire range of the data set. These line graphs here, I find are really easy for me to understand. And what I particularly appreciate is we had the inclusion of a filter here, which allows us to kind of go and start exploring how that trend changes over time. And we have these dynamic subtitles that are changing when I update my filter selections to help provide that clear context into the trend that's being visualized. In some of the remaining sections, we see the exploration kind of narrowed down to those last 10 years and through a couple of different lenses, things like the most frequent cause, geography, and the way customers are impacted. Now, it's potentially because we are seeing like some of that drill down in detail that we're also noticing that there's a lot more text that's required to contextualize and explain some of the insights. And, from my own practice, landing on the optimum amount of text is such a hard balance to strike. But I do think there are some opportunities here that Katie might consider leveraging from the key principles in advanced dashboard design to just help condense some of that text load. So for example, when I was reading through the text, I found some sentences that might just make amazing eye-catching titles. So an example is this one down here at the bottom left corner. Now, envision if this title, which is describing exactly what's happening in the graph below, was moved up to the beginning. Not only what it would give for the viewer is like a little bit of enticement to understand what are the two top event causes, but also it would help condense some of that text load that we're seeing there. So a really great way to kind of keep those insights and just draw even more attention to them. The other thing that we see Katie has done really well is making sure that we have consistent coloring of different event types across the dashboard. So there might be an opportunity here to kind of rearrange a little bit so that by common positioning, we can reduce the amount of text that's required in each individual graph in order to provide like a legend for what's happening with event types. Finally, I wanted to close out by talking about this insightful graph here. And Lauren, in your review, you almost foreshadowed this one a little bit. This is an examination by Katie looking at total demand loss geographically by state. But Katie made the decision to put each state into a common scale. And that's by taking that demand loss and representing it as per 100,000 people or per 100,000 population in the state. So if you just use the raw data totals, California and Texas, and I think Bronislav, you mentioned this, stand out as having the total highest, but they also have the largest populations. So standardizing the unit of measure to per 100,000 population has allowed Kate to uncover some nuanced insight here around impact in states that counts would kind of just not show the same way. So really great stuff here. Thanks, Katie, for giving me the opportunity to provide a talk through of your awesome work.
Awesome. So digging into Kurt's report, there's a bunch of stuff that I really liked, and there's a lot of things that I think Kurt did really well. And I'll kind of dig into that in a little bit of detail. I think one of the biggest areas of opportunity here for you, Kurt, is to really kind of focus on your analysis and the way that you're kind of structuring the dashboard. And making sure that you're very clear on the exact kind of story or stories that you're trying to tell there. So again, I'll provide some more kind of specific feedback there, but from a high level, that's kind of my overarching feedback. So first up, I really like your LinkedIn post where you were calling out Rick and Gerard, that you had used some of their content and their sites and stuff for inspiration and as references. Rick has a ton of awesome Power Query related content. Gerard put together, I think, more than an hour and a half worth of video content showing, which is just amazing, Gerard, but showing all of the steps that he took to clean the data and how he approached solving a lot of the cleaning and transformation steps. So awesome that you're using that content for inspiration and to help you. And again, just like writing a research paper, just make sure to cite those sources and, kind of call out those folks when you are using their content for inspiration there. So, again, from a high level, I like your approach here. I think you do a good job within your report here, calling out some of your key assumptions and talking about some of the transformations that you end up applying to the data and some of the overall approach that you're taking with the data. One of the things that I really liked was this, if this was the real world, that kind of a call out where you're starting to think in context or in terms of, hey, if I was actually on the job right now and had access to engineering or development teams or, folks that had maybe been with the company longer than I have, there's a lot of occurrences that pop up in these data challenges where you could potentially ask for more detail or more insight into hey, how would you handle some of these values or some of the occurrence of these null or unknown or, those types of values there. So I really like that you're calling that stuff out explicitly within your report kind of feedback and detail about the project. So kind of scrolling down here. Again, you've got a lot of those great assumptions. One of the things that I really like that you're calling out here is this whole example of the try and otherwise logic in M code. I haven't seen a ton of this, but this is a really, really powerful process to use when you're specifically trying to handle errors within the result. So this is especially true when you have reference columns that contain inconsistent or variable values or data points, which again, you're calling out the different types of format strings that you're looking for and the culture or the way that the data is supposed to be formatted, within those columns. So this is a great method here. There's a ton that you can do within Power Query for error checking, where you can produce your own conditional error handling logic. So this is a great approach to take. kind of going down to the emergency, event types, state types, all that stuff. I think you did a really good job kind of highlighting the main purpose of your process here and then talking through the final outcomes. So from a data cleaning standpoint, I love what you did here. I think you took a very thorough and logical approach working through this. It looks like you were able to get everything in a really, really solid format. So kind of transitioning into the report and data modeling pieces. Really nice work with the data model here. I very much appreciate that you took the time and the opportunity to break out separate calendar and time lookup tables here. This approach is generally very good because it provides clear structure within the data model. It improves your data model performance, right? And then it also makes it a lot easier to work with those time-based columns or the time-based values or data within Power BI. So love that you took the time to do that. Kind of scrolling down here, we'll scroll past some of these visuals here. And actually, you know what? We'll just jump over to the dashboard. So from the dashboard standpoint, I really like the kind of overall layout, the use of color. I like your use of text to clarify and kind of call out your key points here. So from an aesthetic standpoint, it's easy to kind of look at and start digging into the different kind of components. It looks like there's kind of 4 quadrants that are set up here. So kind of getting into some of the constructive feedback here. I think one of the overarching challenges that I really had with the dashboard is that the more I dug into it, the more questions I ended up having about it, or the longer it took to try to interpret actually what was going on. So couple of examples of that. One thing that you do really well is these events that are causing demand loss for the current year, saying it's weather, right? Like within the data set, like that is pretty prevalent. We can say from a volume standpoint, weather is one of the biggest, or it's the biggest contributor to demand loss within the data set. When we start trying to look at when we're trying to slice that demand loss by other categories like state, for example, right? So if we take a look at this top right chart, as a general rule, and Lauren has talked about this a little bit, we just saw a great example with Katie's report that Stacy presented. One of the things to make sure that you're doing is to basically clearly define the purpose of your analysis and what the specific goals are, right? So each of these charts should have a very specific and defined purpose. And when you're trying to understand when you're looking at something in terms of the absolute value of an event, like this was the volume, there was 1,000 events happened in this state, or there were 100 events that happened in this state, right? Make sure that you're focusing your analysis. So you're either trying to determine the total volume or the relative frequency or intensity of that event compared to something else, right? So like Lauren and Stacy have already kind of talked about, when you start looking at something like the number of customers that were impacted by states, it's logical that California and Texas and some of these higher populated states are going to show up in that upper right block because from a volume standpoint, that's where we see it. So I think one of the areas of opportunity here for you and with a lot of the other project submissions is to make sure that you are adjusting the impact for population size, right? So adding in, those types of controls to make sure that you are kind of comparing apples to apples. All right, kind of jumping over to the top left visual here. Again, I think one of the other thoughts here is that, Enrique talks a lot about this in his advanced Excel dashboard design course, is that, visuals become very impactful and clear when there's kind of nothing left to take away, right? You've got all of those kind of key elements and attributes there. And I think one of the pieces that's challenging about this visual specifically is that it's hard to understand what represents what. So we're talking about a year-over-year analysis or current year compared to last year. Does the area represent current year? Is that last year? If this is 2013, we have a partial data set for 2013. So is that why things dipped down here in July, kind of June, July timeframe? If we had included an x-axis here, we could get a little bit more detail into, what values are represented by the shaded area region here. The average events per month. Again, we don't really have any detail into that as well. So again, I think adding an x-axis here would be really impactful, or probably the most impactful piece that you could add. I also think using something like a dual line chart here would be a great way to kind of clearly show current year versus last year, and then add in some kind of color shading or something like that to really call out, like, this is the current year compared to the last. I do like the tooltip here. I think this is a great way to add additional detail and context for each of the data points. But as an overall kind of point of feedback, whenever you've got a visual on a page, it should really pass that 10-second rule. It should really be able to interpret exactly what's going on with it within 10 seconds. And I kind of struggle with that. So yeah, all in all, I really liked the work that you did here. You did a lot of work to get the data cleaned, transformed, and prepped and modeled. And I know it's a ton of work and effort, and I think you really nailed that side of the project. I think you've got a great structure for the dashboard too, but would encourage you kind of to just tighten things up a little bit from an analysis standpoint and really make sure that you're using proper visuals and accurate comparisons. So yeah, overall, great work.
All right, so our final finalist here is Agatha. And there's a couple of things I liked about this report, and I'll come back to the dashboard in a second. But the first thing was that for the data cleaning steps, I think what they did was to really call out the steps and the assumptions that they took in each step. It just kept the focus there. So there's not a lot of technical detail here, which it can be very easy to get lost to and can make these descriptions get pretty lengthy. But here it was mostly focused on, all right, I had to take these steps. This is why I had to take them. And if I had to make any assumptions, like, for example, when replacing values, if I had a value of evening, then I made it 6 p.m. So it's very clear what decisions had to be made and how she took them. So I really appreciated that. There's some other ones here as well. I think you could have been a little bit more concise in this little list here with how she grouped the disturbance events. I think maybe just keeping the high-level groups like environmental factors, equipment failure, human factor, et cetera, and then maybe getting rid of the underlying ones in here would have helped just get rid of this big white space here. I also really liked, you'll see again here, for example, some of the assumptions, the rows with a number range, and then the demand loss or the number of customers were replaced with the maximum value. You might disagree with that, you might not, but at least you know exactly how these numbers are being cleaned up, and I appreciate that. And then I think after that, we'll see the patterns and trends and the weak points in the grid, and a lot of the insights here are exactly what we were asking for in the challenge prompt, which I really like. The only thing for me, there's a lot of good stuff here. I know we've talked about this a bunch, but again, California and Texas experience the most, but she does call out that it's important to normalize it because these are the largest and most populous states. The problem for me is that once we go back to the report, that doesn't show up in the actual report. You'll still see Texas and California as the darkest shaded states. So I love that you noticed that. I wish it had been implemented. Maybe that's part of a V2 sometime down the road. But I really liked a lot of these insights. I think they're very strong and they specifically addressed what we asked for. The weak points in the grid, again, a lot of good insights here that I wish had made it to the final report. So if I go up there, we've got some recommendations for data collection here too. And then we've got the report. So we've got a very nice summary up here that kind of adds some context into the total number of customers affected being pretty much the US population. At this point in time, naturally, these are the customers affected during the 20-year span. So again, very nice KPIs at the top, average restoration time. And we do have a very clean looking dashboard. We can filter it, loss instead of number of events. things like that. But again, this is not normalized data. So we're seeing the big, California and Texas shades all over the place. We've got the types of events as they were grouped. And if you want to dig into each one, like just weather, then you'll see the different subcategories. We have the heat map, which is similar to Martin's. I just don't think the color scheme works very well here because it's almost like you're looking at the sun, right? You can sort of tell that this is where they're concentrated, but not really. I think using a different color scale would have been key and a very easy adjustment to make here. Other than that, I really like this part here where you can just kind of drill down by the types of events into the different metrics. I love the use of these data bars. As you kind of expand, you can see those dynamically change as well. And then finally, we have, again, some more context here in saying that the 10 largest outages in the last 20 years account for the 10% of the total customers, which is crazy considering there's been, almost 4,000 events, but 10 represent 10% of the total damage. So again, I think like some of the best insights here are just kind of hidden in this text, in the text down here, but they didn't really make it to the full dashboard. Even though I will say that this is a very clean dashboard made out of very messy data, and I can tell that they did a great job cleaning it, so I will add points for that. So overall, I think, again, great analysis, great data cleaning, great looking dashboard, but I think out of all the insights that were found here, they should just be more reflected in this final report, which is likely what the end user will see anyway. They'll just take a look at this, say, yeah, well, I know it's Texas and California. What else is new? So that's it for the finalists. Now, before we move on to the selection process, I do want to quickly recap the challenge prompt here, which is to clean and prepare the data from the Department of Energy and create a dashboard to explore and visualize the electric grid outages over the 20-year period. And we're judging each entry in terms of the complete project. So every element on the project page that we just reviewed plays a part, not just the visuals. So having said that, are there any strong initial preferences for a winner for these 5?
So I'd like to jump in and suggest that we consider Jasmine's project. I know Lauren mentioned like the opportunity to maybe refine the analysis down to 100,000 K population for common scale. But I think, Lauren, you did a really great job of explaining not only the effective use of Excel to be able to clean such a very messy data set, but also the choices and how they really lended itself in the final project to communicating the over insight. So when I think of it from, that overall package of meeting the requirements of the challenge, Jasmine stands out to me.
Yeah, I will say Martin's was really impressive to me. I thought it was a really, really clean dashboard. I really liked kind of how Bronislav explained some of the groupings. And I think that I loved that heat map. I think that, that in particular really draws your eye. And I like the call outs that kind of go along with it. So I think that Martin's is a really strong contestant here.
Yeah, one of the reports that I really liked was Katie's. I like that it is focused and that she took the time to add in the population normalization stuff when comparing. The one knock, if we are, looking at the challenge prompt, she purposely chose to only analyze a 10-year period, and we talk about it over a 20-year period. So there could potentially be a small argument there where, projects that, incorporate all 20 years, are actually following the challenge prompt to the T versus, saying, hey, I'm going to only take the last 10 years of data and look at that. But I think that she does a ton of great stuff. And again, I very much value that focused approach when you're conducting an analysis like this, especially on such a long or wide data set.
I was gonna also mention Katie as an option. I'm going to upvote Martin once again, but there is something about Katie's work that's, despite the fact that it's not full 20 years, which I agree is very debatable, but I really like the normalization piece. And plus, she did a good job, even if the dashboard as a whole feels a little bit cluttered. She really did a good job, like pointing out some of these huge, almost anomaly-like events, like, I don't know, jumping. There is a top 3 event chart in the upper right-hand corner where we see an increase of 300 something percent. And then again, in our NERC region, quick stats, there are some anomalies like 900%. So she did a very good job. And this was also a part of the challenge prompt. She did a really great job in calling out these unusual values and then like really enticing actions to enticing actions like to dig into those things and see, hey, is this right? Like, is this possible, or what's happening here? Or is it some sort of a like error in the analysis or the data, something? So it's a very, very specific call to action. Plus, as Stacy said, the dynamic subtitles, which actually draw more attention than the titles themselves, and again, screen these very important details. Like when we see these line charts, yeah, okay, but when we see, hey, this jumped 1,500% over this period of time, so that's a whole different universe where our mind is in. So yeah, I will definitely second Katie's.
And I'd actually like to rescind my previous statement about only including 10 years of data. So I clearly misread part of the report. She did clean all of it, and that's included within the data. Just chose to focus the kind of analysis and some of the visuals on the last 10 years. So I don't think that that's an actual issue. So sorry about that.
All good. Yeah, I think I agree with those three. I think Katie, for me, had the most unique insights, and I think they were shown in the visuals and not just the text. I think Martin very clearly addressed the 3 points in the challenge prompt, and it's very easy to follow his conclusions. And I think, yeah, Jasmine, I hadn't noticed it until you presented it, Lauren, but I think the interactivity in it made it unique for me as well, and just kind of made me want to dive a little bit deeper into it. So I think these are 3 worthy contestants for the top prize here. And if we're ready to vote, we could do Jasmine with a 1, Martin with a 2, and Katie with a 3, if everyone has their vote. All right, let's do this. 1, 2, 3. And it looks like Katie takes it 3-1 to 1. All right. Let's give her a round of applause. Congratulations.
Nice work, Katie.
A nice
really
little applause from me. So Katie, congratulations once again. As a prize, you'll be taking home a free annual membership to Maven and a custom Maven Challenge Winner t-shirt. So congratulations. That's it for this challenge. Thanks once again to everyone that continues to participate. This one was harder than usual, so we double thanks for that. We've got a lot more in store for you guys in 2024, so stay tuned, and thank you.